Like, so if you made it to this video, that means you made it through all of my blabbering in the research portion, or you decided to skip the research portion altogether and go straight to development. If you did do that, I suggest going back and watching the research videos, because there are a few things that I'm not going to explain in depth, since I already did the yapping in the research portion. So there's some things that I'm going to run through here, and some things that I'm going to explain more in depth. So just to make sure you're well-rounded, go back and watch research, and then come back here if you decide to skip it. Okay? Okay. Alright, now it's time to code. Now let's go ahead and make a new project here. And instead of making a console application or a Windows Forms application, even though these two are basically the same thing, just one option, flip to turn the console off, so you can only see the window. We're going to make a class library, and let's just name this SockSlib, because I'm horrible at naming. And also, if there's any background noise or any heavy background noise, I apologize for that. And if it starts getting too loud, then I'll just go ahead and pause the video and continue when it's done. What we're going to do is, we can use this class, but let's just go ahead and delete it. And let's add a new item. And we're going to do this based on the pseudocode we did in the research portion. Yes, also I changed this around. I did call it TcpListener, but then I realized there already is a TcpListener herder, so we're going to name this TcpSocketListener instead. So let's go ahead and make a new class and name it TcpSocketListener. One of these two, we could do either one of these first. I'm going to do the TcpSocketListener first, because we're also going to stress test it. It's easier to make a connection socket than it is a listener socket. So I'm just letting you know that you could do either one first, but the chicken or the egg, you got to choose which one comes first. But we're going to do the TcpSocketListener first. Okay, and since this is going to be a library that we're going to use in that we're going to reference and use in our other applications or external applications, we're going to make sure we make every class public, so the other assemblies can access these classes. And since no other class is going to be using this as its parent class or its inherited class, so we're going to go ahead and make this sealed. This is just so nothing can inherit this. Now that we have our bare class set up, we need some additional parameters for this thing that we're going to straighten out here. So of course, the socket was created, blah blah. We bound it to the port and the IP address of the computer, listened, and then we did this loop to accept connections. Now again, using this in an actual application is not going to work out very well, but we're going to use begin accept and the callbacks, and we're also going to add an event later on that we mentioned beforehand in the pseudo type. So what we need is to handle or listen and accept the incoming clients, and we're also going to create a event for the applications to receive the accepted socket. So before we do anything else here, let's go and make a new class. This is going to hold all of the event args that I mentioned before. I'm going to name this SockSlib event args, and go ahead and get rid of this class. And we'll make a new public class, accepted socket event args. And as a matter of fact, let's name this accepted TCP socket event args, since that's essentially what this is going to use later on after we code the TCP socket. But for now, we'll just use a bare socket as the placeholder. We'll have a public socket. sockets. Make sure we include our namespace. And we'll name this property accepted socket and private set, since the socket is going to be set inside of the constructor and we're not going to need to set it anywhere else, wherever this class is instantiated. We only need to get from it. This basically means public get, and you can see here private set. And then we'll make a public constructor for the TCP socket, and we'll accept the socket as the variable. And we'll set the accepted socket, which will be the instance of this class, to the socket that's being passed. And you'll see where this ties in once we go back to the TCP socket listener. And we could also add a couple of other variables here, like the endpoint of the socket, which is just the connection point of the connecting socket. Sounds very redundant, but we'll just add IP endpoint, and we also need to include system.net. It'll be remote endpoint. Let's call it remote endpoint. Just keep things uniform. Same thing as above. Get private set, and then this dot remote endpoint equals s dot remote endpoint, and we'll just cast it to an IP endpoint. So this way, after the client is accepted and the event is fired, if you need to check the IP endpoint against, say, a blacklist database or something like that, see if the IP address is banned, you can just go ahead and grab it directly from this class instead of having to go into the socket to get to the remote endpoint. Just to make things a little easier, depending on what you want to do for your application. And now we'll go back to our TCP listener, and we'll go ahead and include system.net and system.net.sockets, of course. Now let's go back and look at this. We created in the Microsoft example, they created a listener for the socket, so we'll go ahead and do that. But this is going to be in a variable instead, and not a method variable, a class-wide variable. So we'll do private socket listener, and we're going to add a couple of properties in here too. We'll add a boolean named running. This is also going to be private set. Nothing outside this class needs to set this. This would be for if the listener is running or not. So say you instantiated this listener and you wanted to check and make sure that this wasn't running before you decided to spin off another listener. This is just, again, depending on your application. You may need this, you may not need this. It all depends on how you set up the structure of your external project, but it's just a nice little thing to know, just in case you need it. Another variable, another property we could use is an integer named port, so you know what port essentially, so you know which port this listener, which port this listener is using. If you have a list of socket listeners and they all have different ports, but you say you need to get the listener of a socket listener of one that has a certain port, you could use this property to filter that and find that instance of that listener. And other than these two, that should be it. And also, if you could also combine these two in, say, a link query and make sure that a listener either doesn't have this port, they're not using this port, and it's also not running. Just one of those little tidbits that you can use. with these properties. And with running in port, I would say that's all we need property-wise. Now we need to add an event. So if you've used events before, then you know you can go and make a delegate method, function pointer, whatever you want to call it, like public delegate void, blah blah. Socket accepted, so forth and so forth. We could do something like that. But what I like doing as of late is using the event handler delegate that's already set up. And all we need to do is use the accepted TCP socket event args, and then we have let's name this accepted. And this way we don't have to write any other delegates or function pointers, whichever one you prefer to use. And the event will use this class that we just created. And you'll understand how we use this later on in a little bit. So we have our properties, and we have our event. Now let's go ahead and make our constructor. We could pass the port into the constructor, or we could pass it in our start method. We'll just use the constructor because. And then this .port is our port. And I realized I could just do this so you can see the code a little better. Oh, that looks weird. But anyway, we're making our constructor for this class, and we're going to pass the port and then set the port to the passed variable. Now we need this thing to run, so let's go ahead and make our start method, and we're going to check if this instance is running. If it's not running, then we will go ahead and run our code to start up our socket and to listen for incoming connections. So our classified listener equals a new socket, first bound to internet network, socket type .stream, and protocol type .tcp. This .listener equals, this .listener bind new IP endpoint, IP address loopback, and then the port will be our property. Now this looks a little different from the Microsoft example. In the Microsoft example, they resolved the DNS of the host name, they got the first IP address, and then they created their local endpoint they used for binding. In our case, and especially in my case, since my host file is not quite vanilla, and I have a bunch of funky stuff going on in there, and also my computer is IP6 enabled, as most computers should be now, and I'll have about 4 IP addresses, and the one that we need will be an IP4 address, and we could loop through all of the addresses to make sure we find that one, but that's just too much work. And it's not really necessary. When all we have to do is bind to the loopback, and then any connection can be accepted into our train station. And then we're going to call begin accept. We don't have our callback yet, so we'll just put a placeholder here. We'll name it just accept callback, just keep it simple. And null. Now in the Microsoft example, they passed the listener into the async state, but the reason why they did that is because they made the listener in a method variable instead of it being global like we have it set up right here. So we don't need to pass anything into the state object. So now that we have our start method done, we're just going to leave this here for now. Let's go ahead and just code our stop method too. Public void stop. And also we need to set running to true. so start can't be called again from the same instance of this class. Now we'll stop. We're going to do the same thing we did up here, but reversed. If it's running, then we'll call listener dot close and shut down our socket listener. And let's also set it to null too, so the garbage collector can clean it up. And then I always forget, we're going to set running to false. Okay? This looks good. We could also throw an exception if we wanted to, just to run off that same structure. Just throw a new exception. TCP, or yeah, it's called already running. And else, we could throw a new exception. You don't have to do this, but if you're going to use this in multiple applications, or you want to add your little flavor to it and make this a public library of sorts, then you should have an exception system in place, just so people know when something went wrong, or why something went wrong, I should say. And to make this more specific, let's make this an invalid operation exception. Okay, and that looks good. Let's minimize these two. Now let's code our accept callback. So we're going to make this private void since nothing outside of this class needs to access it. Accept callback, our async result. Now this needs to be inside of a try and catch statement, because if end accept fails, then it will throw an exception. So we need to make sure to catch this, so if they do stop the listener, the entire program doesn't crash. Now let's make a variable named accepted equals this listener. You don't have to use this. The main reason why I use this is to keep the method variables and the global variables separated. Especially if they're kind of similar named, I want to know that this means, okay, this is a global variable, and if it doesn't have this, then it's a local variable. That's my style. That's how I play. You don't have to do it. I suggest it, but you don't have to. You could just do listener if you wanted to, but I'm doing it this way. This dot listener equals end accept AR. Now this looks similar to what we did, or what they did in the Microsoft. We didn't actually execute this. I'm just going to say what they did. What Microsoft did in this example, that's a little different from ours, is they got the listener socket from the async state, which we didn't have to do because we have a global variable for that. And then they called end accept, which is what we did here. Except we're not going to need any of this mumbo jumbo that they have down here. You'll see where the difference lies in our class. So, and now that we accepted the client, now we need to call the event. So accepted, we're going to use the nifty little, if it's not null. That's basically what this means. If it's not null, then we're going to call this method. I love this little nifty thing. Before, you always had to do if accepted is not equal to null, then you have to do accepted blah blah blah. But with this, we can just call if it's not null, then we'll invoke the event. The sender is going to be this in the instance of this class, and then our new accepted TCP socket event arguments, and then we're going to pass our accepted client. And that's it. Now, if an exception is thrown, I'm going to go ahead and print the stack trace. to our debug output, to any debug listeners. We could also use console. I'm gonna go ahead and use console for this portion. We could use console, we could use trace, or you could write this into your own type of debug file as well. We'll just use console for now. And that is about it for the TCP socket listener. So what we did is we took this right here and turned it into something that we could always reuse. Let me make sure, and there was something I forgot that I always forget as well. This.listener.listen, the main thing we need to do. And the backlog, which is just the maximum amount of connections that can be pending. I think I explained this in the research portion. If not, I'll just go ahead and explain it again. If a lot of connections are coming through, say you have a maximum queue of 50 connections, 50 connections will sit and wait their turn going down the line to be accepted by our begin accept and end accept methods. And if there are 51 connections, instead of the connection hanging, which is it waiting to be accepted, it'll just instantly be cut off and say, okay, the connection was reset. So that's what listen does with the backlog. So in this instance, we can accept a maximum, or have a maximum of 100 connections in the queue. Or I think if we used 0 or -1, then it's however many connections the system itself can handle. But we'll just use 100 for now. And now that we have all that straightened out, let's just go and make sure that everything looks good. Okay, accept the connection, and then we call the event. If you're using an earlier version of the framework and you can't do this, go ahead and do if accepted is not equal to null, then call accepted our event arguments, and it's essentially the same thing, but we can break it down and simplify it to this. Okay, and that looks good. Now let's go ahead and test this. So let's make a new project. It'll just be a console application, and we'll just name this socks.lib test. Okay, and let's go and add a reference to our socks.lib. Since it's in the same directory, we can just go ahead and go to projects and solution. Nice and simple. And then we're going to include our socks.lib namespace. And let me think of how I'm going to actually test this. Okay, so what we're going to do here is we're going to make a new instance of our socket listener. And we'll use the port 1000, because why not? And then we'll register our accepted event. I'm just going to use a lambda so we don't need a method. And then listener.start. And inside of here, we're going to do console.write line connection argument accepted. And we're going to have a connection count variable that we're going to make in a second. Okay, and let's make variable int connection count equals 0. We'll have connection count plus. This means increment by 1. And then I'll write the console the connection count that was accepted. And here we're starting the listener. Now to actually test this, and we're going to do this all inside of one program. We're not going to make 2 for this test. We're going to do a for loop of 10. We're going to instantiate a new socket and use system.get.sockets. And then we're going to have connection count ++. And then specify for client equals new socket, address family internetwork, socket type stream, and protocol type TCP, like you guys already know, and then we'll use client.connect, the new IP endpoint. What I did was I just included system.net using a shortcut. An IP address dot loop back, since we're just connecting to our own computer using port 1000. Where is this thing breaking out about? Oh, wrong spot. Herder. Okay, and we'll have console.readline, just so it doesn't shut down on us. Now, what should happen is it'll instantiate the listener, register the event, start the listener, and then here we're going to connect to it 10 times. And let's also shut down the socket after it connects. And let's see if this executes correctly. Oops. Set this as a startup project. Connection 1 accepted. I knew that. Little things like that happen sometimes. But hey, it's good. Something like this happens, then you'll know, okay, so that's what caused it. We forgot to call listener begin accept. We forgot to start the loop again. Callback is going to be the accept callback, and the state is going to be null, just like we did in the start method. Now with this in line, now it should work just fine. And there we go. 10 connections were instantiated. 10 connections were accepted. Just fine. Now let's go back up here and to just show you one of the properties in our event. We'll have e.remote endpoint. We'll just have this right to the console. And voila. This is how we accept multiple connections with a usable class. So what we did here, again, we took what we learned here, took out all the crap here that's not even needed for a real-based application, real-life application, and turned it into something that we can use in several. Let's go back through here and let's recap what we've done. And you know what, just for the fun of it, let's stress test it. Let's try 1,000 connections and see if everything works just fine. And all 1,000 connections went through and were connected. Awesome. Now let's recap. Up here first with our properties, we had a property if the listener was running. And actually, let's go ahead and test these out too, so you can see why I have these here. So now that we know our connections work, let's go ahead and get rid of the event. We don't need that there for now. Now that the listener is started, if listener.running console.writeLine, you can't run it again, else let listener dot if I can type listener.start and then console.writeLine. Listener has been started. We don't need to either. Okay, now let's go ahead and run this again. Oops, you can't run it again because we just started the listener back up here and we check to see if it was running first. Since it was running, we're not going to do anything with it. We're not going to try to start it again. But if it's not running, then we went ahead and started it. Let's try that first. And the listener was started. Now, if we didn't listen to our nice little methods and we tried to start this, say, twice, then we should get an exception. And yet the exception was thrown that the listener is already running. Same thing with stop. We did listener.start. If the listener is running, then we're going to stop it. If the listener is not running, then there's nothing for it to stop. And as you can see, an exception was thrown, and it was written to the console, because after we stop the connection, after we stop the listener, then endExcept is going to throw an exception because the socket was shut down. And I'm going to go ahead and breakpoint this so you can see it. Okay, so here you can see endExcept is about to be called, and then the exception was thrown. Object reference is not set to the instance of an object because we shut it down up here, so then it became null, and then the exception was thrown in the callback, which is why we need to wrap all of the callbacks in exceptions, in try-catch statements, to prevent things like that from happening. And let's go ahead and change this to debug.print instead of console.writeLine, so we can see it in our output window instead of it being on the console itself. But now returning to our tests here, if we called, or actually if we didn't start it, then there's nothing for it to stop. But if we happen to call stop before listening in on the socket, starting the listener, then it'll throw the exception that it's not running. So now it looks like everything is actually running just as we expected, and port we actually don't have to test because we know that it's working just fine. Because otherwise, how would we be able to actually listen in on the socket? But let me also explain to you how that could be used, or how that could be useful. If we had a list, you don't have to actually type this out unless you want to test it yourself. If we had a list of listeners, and we added, say, 3 of them, one had port 1000, another had 1001, and another had 1002. And we needed to get access to the first listener to see if it was running or not. We could use a link expression, or a link method, listener equals listeners dot first for default. That means the first one, or if it's not found, nothing. And then we'll use X, which will be the listener, or what we're checking against. If the port is 1000. If the listener is not equal to null, meaning we actually found an instance that has this expression right here, which is the port is 1000. X is just the instance, and then the instance port is 1000. Then we'll right line listener with port 1000 state, which would be an argument, and then we'll have listener dot running and this right here, this is basically, if you want to look at it in a simplified way, it's a simplified if statement. What we could do with this is, if listener.running, then console.writeLine active, blah, blah, blah. Just look at this as a shortened if statement. If this is true or false, then the first block is used. If not, then the second block is used. But what we're doing with this is checking if there's a port in the list that has 1000. If it does exist, then we're going to write and see if it's actually active or not. So let's try that out and see what happens. Right now, the listener is inactive. So listener found port 1000. Let me make this 104. Okay, no listener found with port 1000. Let's make this 1000, and it's also started as well. So we're going to go to the first listener in the index, which is going to be this one right here, and we're going to go ahead and start it up. Now this should say active. And it does. So that's one example of how you could use those variables. If you had an application that was using multiple listeners, you don't know exactly where it is in the list, and you need to target a certain one based on a certain port. Or you could also do, if you only wanted to pull listeners that were running, just something you could do. But now that we know that our TcpSocketListener works just fine, let's go ahead and recap what we did here. It's quite simple. We have our property of running, so we know if the instance of this class is accepting connections or not. We will store the port that the listener is using, and we're also using this property. When we instantiate our socket, we have our event. When a socket is actually connected, we're storing the instance of our listener in our listener variable. In our constructor, we're passing in a port that we're going to use, and we're sticking it in our property up here, so it's global, to this class and anything outside of it. In our start method, we're checking if our listener is actually running, and I should really add this and this, not following my own style. And, well, anyway, back to this. We're checking if our listener is actually running. If it's not running, then we're going to go ahead and do what we're doing. We instantiate our new listener. Just do this so you guys can see it. We instantiate our new listener. We're binding the listener to our loopback address using the port that we passed, so we can accept any connection on this port. We're setting the socket into a listening state, so it can begin accepting sockets with a connection queue of 100. We start listening in on our socket. We're starting to accept connections on the socket, and then we set running to true. Down in our stop method, first we're checking if it's actually running. it is, then we shut down the socket, set it to null so the garbage collector can nom it up, and then we also set running to false. And for both of these, if it's vice versa, then we throw a couple of exceptions. In our except callback, again, we're wrapping. Main thing we're wrapping is end except, because this is the only thing. Well, actually, there are two things. This and this could throw an exception in this method. So we're wrapping them both up just in case. And after we call end except, which passes the reference to the socket that's connected into our variable, then we call our accepted event, and then we start our loop again and accept another connection. If something screws up in here, we catch the exception so the whole application doesn't crash, and we also print the stack trace to the debug output. You could also use trace as well. I would suggest using trace instead, or use trace and debug, either one. But I always suggest writing your stack trace somewhere, because you don't want the exception was thrown in your output window, and you have no idea where it is. Then you have to go through your entire application, pull out every single try-catch statement, and see where it actually happened. If you at least write the stack trace, you know where it happened. Okay? Okay. But now that we have our TcpSocket class done, what we're going to do in the next video is, instead of passing a raw socket, we're going to wrap up the socket class into our TcpSocket class, and then this is going to handle all the nitty-gritty stuff that we have to do with every single application, basically, from scratch, which is why we're wrapping this up so we don't have to deal with that issue. And this looks good. Okay. Now let's head on to the TcpSocket. There was one other thing that slipped my mind before we move on. Head back into the TcpSocket listener and flip these two lines of code. Make the event callback after we begin accepting another connection. The main reason why we're doing this, and I forgot to mention this in the previous video, it's the same video, I'm just putting this at the end of the video, is that the event that we call is going to be using the same thread that calls the accept callback. Now, if you're doing a lot of things inside of the accept method callback, then it's going to take a little time before we can begin accepting another connection. But if we call begin accept first, then the system's going to start doing its thing with accepting another connection, and then we can call the event, and then the callback can take as much time as it needs doing its own thing while we're accepting another connection. So that's just one last thing I wanted to add on to this video. Now we can move on.